All right, here we go. That last chapter we talked about area, and we're going to talk about area again. But on that last chapter, we just talked about area of a two-dimensional figure. Okay, just stuff that was flat, didn't have any, any don't want to say height, but any depth to it. Right. So what we're going to do today is we're going to deal with things that are three-dimensional, and that's what these things are. Okay. So we're not just going to talk about a rectangle, but we're going to talk about like a box. Okay. Find the area of like a box, or instead of a circle, we're going to find the area of a cylinder. Instead of a triangle, we'll find the area of a prism. All right. And so we're going to talk about a few of those things. So that's what chapter 12 is about. I'm going to teach it just slightly different than what the book does. They give you all these brand new formulas to remember. I used to teach this out of another book, and I really like the way this other book approached it. And this book kind of does a little bit, but anyway, it might be a little bit different than what this book says. So let's talk about the very first one, and that would be let's see what I want to do first. Looks like they have Prism first. I'd probably go somewhere else with this, but that's okay. We'll go Prism first. Now, I took a little bit of time at the beginning of class. I should have done this last night, and I just didn't think about it, but that's okay. What am I doing? Place. I went through and I just found some pictures because it would just take me forever to try to draw these three-dimensional pictures. So I found some on the internet that I thought might work for what we're doing, and let's do this one. Hopefully these work because they're all... Some of these are PNG files like that one. Some are GIF, GIF files. Some are JPEGs. So hopefully this works. Yes, it does. Thank goodness. Beautiful. That looks better than I thought. What's that? You can't see it? Or you can't draw it? Right. I know. Well, that's why I grabbed them from the internet, because I'd have a difficult time drawing this myself. All right, but this basically right here is a prism. Let's just talk about this a little bit. Now, it depends what kind of prism. There's all kinds of different shapes of prisms. This is one, it's got a top and it's got a bottom. So what do you think we're going to call those two things? The bases, right. We'll call it the base of the prism. And then we got all these sides. You see this front side, this side, and then you can kind of see through it. See, I would have never been able to draw this myself. But you can kind of see through the back here, this side. Right, you've got all the sides, you got the top and the bottom. So what we're going to do today is we are hopefully going to figure out the surface area. So we're not just going to say find the area of it. It's basically the same thing, but we want to find the total surface area of a prism. Now, depending on the base, depends on the shape of this thing and what it looks like. You could have a prism with like a triangular prism. That means the base would be a triangle. You could have a rectangular prism, which means the base would be a rectangle. This one right here, I just grabbed this one. What is this? 1, 2, 3, 4, 5, 6. This is a six-sided figure. So what kind of prism? Yeah, they probably call it a hexagonal. Doesn't that sound cool? Right, or a hexagon. Prism, right? Hexagonal. I guess that's how you'd pronounce it. All right. So, now the nice thing is about what I'm going to show you is that you don't really have to learn a different formula for each different shape that we do. Well, you kind of do a little bit, but I just want to show you something in general. So the surface area of the prism, basically, it's made up of three different parts. All right. So the first part would be the top. Okay. Now the second part, we could call this even like 1A. You don't even have to call this 2, I guess. Would be what? The bottom. Now tell me something. On a prism, now these lines, now they kind of slanted this picture a little bit, so it doesn't look like it's exactly straight up and down or perpendicular to this, but it is, okay, because it's kind of like a slanted view, the way they drew this. But what do you think is true about this line right here and this thing right here? Okay. They're perpendicular. Okay, they don't have to be equal. This could go up a whole lot taller, or it could be a lot shorter. So it doesn't have to be equal. Okay, but it is perpendicular. All right. So when we talk about this, I should slide a word in there. The surface area of a right prism, meaning it's not slanting. Actually, you know what? I'm sorry. Forget that right part in there. We'll talk about when we talk volume. That'll be different. But the surface area, I think, will be the same anyway. All right, so the surface area of a prism, what you would do is you'd find the top and you'd find the bottom. Now look at the top. It depends what figure it is. It could be a triangle, could be a square or rectangle, could be a a pentagon, it could be a hexagon, it could be whatever, okay? It could be whatever shape it is. And we've learned how to find the area of these different shapes anyway, didn't we? Learn how to find the area of a polygon in that last chapter. So you should be able to find the area of a hexagon. I'm not going to go through all that detail right here on this. Maybe I'll find an easier one. This is just to view, just to look at, so that we could see what's going on. So what else do we have? We got the top, we've got the bottom, and what else? We've got the what? The sides, okay? Now, instead of calling it the sides, they give it a fancy name, and they call it the lateral surface area. Lateral means side. All right, so it just means all the sides. All the sides added up. So how many different faces does this whole side have? It's got 6. It's got this one, right? It's got 1, 2, 3, 4, 5, 6. It's got 6 of them. All right, so 6 sides. It's a hexagon, and it's got 6 of these like panels, I guess, if you want to call it. Everybody with me on that? It's got. But what we're going to do is we're not really necessarily going to find the area of each one and multiply it by 6. I think that's what the book's trying to get you to do. What I want to do is come up with a little formula for the lateral surface area, and I'm just going to show it to you because we are running short on time, so I'll just show it to you. Lateral surface area, I just shorten it LSA. You probably won't see that in the book, but that's what I do. All right, so the lateral surface area, okay, is this. This is basically the only formula, the new formula that you need to learn. It's the perimeter of the base. Oops, let's put that, separate that. Times, that x is times the height. That's very important to remember. The lateral surface area. Now that's not the area of the whole entire thing. That's not the total surface area. That's just what? The area of the sides. Okay? And that's just not one of the sides, that's all of them. So if I find the perimeter of the base multiplied by the height, that's the lateral surface area. If you think about it, it kind of makes sense. Because look at this. We'll call this A and B. We'll call it A and H. All right. Look at this. How would I find this? This is a square, isn't it? How would I find this? I would go base times height. Let's call it B for base. Is that all right? Oops, daisy. There we go. Instead of calling it A, let's call it B. Base times height. But how many are there? There's 6 of them, right? So basically, if I just find the perimeter, how many, right? This side, and then 1, 2, 3, 4, 5, 6. That's the perimeter of the base multiplied by the height. That's the same exact thing as just finding base times height and multiplying it by 6. Does that make any sense at all? So if I wanted to find out all these panels, I could find, right, the area of this, then the area of this, and then this one, and this one, this one, this one. You get it? And then just find the area of one of them, multiplying by 6. You could do that, or you could just find the perimeter of the base. So if I know this, I think these are, yeah, that's good enough. It's just the perimeter of the base times the height, okay? And that's how you find it. All right, so how do we find the total surface area of a prism? Remember, a prism has a base and it's got a height, and the base and the height are perpendicular to each other. It's very important that you understand that. How do you find the surface area? Well, you just find the top. Okay, that would be this orangish, whatever color that is, reddish kind of looking color. You'd find the top, you'd find the bottom, and what do you think is going to be true about the top and the bottom on this? They're going to be the same, right? So basically, you're just finding the area of the top, you're doubling it, and you've got the top and the bottom. Then you got to find all the sides. How do you find all the sides? You just take the perimeter of the base, all right, just add up all the lengths of this, find the perimeter of that hexagon in this case, and then multiply by the height. The height is how tall it is, this thing right here. Remember, the base and the height have to be perpendicular to each other. Okay? So there you go. That's how you find the lateral surface area. Let's see if I was able to get another picture. Let's try this one. Okay? And let's blow this up a little bit. Alright. Now look, now it's not sitting on the base itself, isn't it? It's kind of slanted and stuff, and that's fine. It could be on its side, it could be slanted. But let's think about this. If we wanted to find the lateral surface area of this whole thing, this right here, this red part right here would be considered our base. That would be our top or our bottom. So we would just find the area of this triangle right here. And you know how to find the area of a triangle, right? Just 1/2 the base times the height. So depending on the information they give you, just find the area of this base. Well, what's the other side? See that other side kind of peeking through here? That would be the same thing as this, wouldn't it? All right, so you take this, you add it to the bottom, so that's your top and your bottom. Now, you got to find the lateral surface area, all the sides. So this face, and the other face. You don't have to find them individually, just do what? Find the perimeter of the base. How do you find the lateral surface area? Find the perimeter, I'll shorten it up a little bit, P for perimeter, of the base, and then multiply it by the height. Okay, so let's use a different color right here. So what would the perimeter of the base be? It would be this. Let's make this a little bit thicker. It would be this one plus this plus this. Agreed? That would be the perimeter of the base. Now again, if they give you enough information, sometimes that's pretty easy. Sometimes you got to think about it a little bit. You got to maybe do some right triangle work or something like that. I don't know. It just all depends on what they give you. So it's the perimeter of the base times the height. Where would the height be? Is the height this right here? Is that what we're talking about? Now, we're not talking about that height. We're talking about the height of the prism. So if I took this prism and I stood it on end, what would the height be? The height would be from here to here. Does that make sense? That would be the height of that prism. So again, how do we find the surface area, the total surface area? We want to cover every single surface. We don't want to leave anything uncovered. So we find the top, we find the bottom. That shouldn't be too hard because you got a triangle. Just find the area, the 1/2 the base times the height. Okay. So we've got this area, we've got the bottom of it. We're good to go. Now we just have to find the sides, all the sides. How do you do that in one big shot? Find the perimeter of the base. So I just add up all 3 sides and I multiply it by its what? By its height. And that would be its height right there. This is the base, right, of the prism. And that's supposed to be an E. That's kind of weird looking. Base. Okay, that's the base. And this right here would be the height. Okay, you just have to use your imagination a little bit. Think of this as, you know, maybe turning it upside down, right? And it's sitting on this, on the ground. And then this is how tall it is. Remember, the base and the height are perpendicular, so it can't go off at a slant. This is perpendicular to the base. Again, with 3 dimensions, you got to use your imagination a little bit. You got to kind of picture what this thing actually looks like. All right, does that help at all? Let's look at another figure. I think I grabbed another one here. Let's see. Yeah, let's look at this. It's not the greatest picture. Probably could have looked a little longer to find something better, but that's all right. Get the idea? Now, you could think of this top and bottom a couple different ways. You could think of this down here. Do you see this one right here? You could think of this one. Oops, let's go a little thicker. You could think of this as the base. That would be fine. All right, so that would be a base. And then the top would be a base as well, wouldn't it? So you just find the area of this. So this would be a rectangular prism because the base is a rectangle, and you still use the same exact formula, except the shapes might be different. All right. On the other one, it was a triangle, so you find the area of a triangle. On this one, it's a rectangle, so you find the area of a rectangle. On the first one we did, it was a hexagon, so you find the area of a hexagon. So it all depends on what shape your base is.
So in that situation, it doesn't matter what the base is?
Well, you could have stood it on end and thought of this as the base as well. It all depends. So if you consider this to be the base right here, then this right here would be considered your height, h. Does that make sense? So it all depends. So on this one, on a rectangle, you could sit it on one side or you could sit it on the other side. So if it's sitting on this, that would be your base, and this right here would be your height because they're perpendicular to each other. All right. Now you could have thought of it another way. You could have thought of this as your base, couldn't you? You could have said, well, you know, if I turned it on its end, it could sit on this end right here. But then what would be your height then? This slanted one right here. Do you see that? That's how tall. So if it was sitting on this right there, then if that was your base, then which one would your height be? It would be that one right there. You okay with that? All right. So that's how you do a prism. That's the surface area of a prism. Let's do another one that's very, very similar to this, and that would be a cylinder. All right, and let's go back to whites. So, oops, I was going to put volume. Let's do the surface area of a cylinder. And the nice thing about this, it's the same exact basic formula as we just discussed, except the shape is a little bit different. A cylinder is basically the same thing as a prism, except we give the word cylinder to when the base is a circle. Okay, it's not a polygon; it's a circle. All right. So if I have a base of that's a circle and it goes straight up and down, and if the height is perpendicular to the base, then we call that thing a cylinder. For some reason, we give circles different names, don't we? We never really called the perimeter of a circle the perimeter, did we? We gave it a special name. What did we give it? The distance around a circle is what? Circumference, right. It's the same thing as perimeter, isn't it? It's just the perimeter of a circle. So instead of saying perimeter of a circle, we give it the name circumference. It's the same kind of thing here. A cylinder basically is a prism, but it's a circular prism, and the base is a circle. All right, so I think I have a couple of these. Let's find a nice one. This is a nice one right here. All right, come on. Oh my goodness, that's a terrible one. Can't see that at all. Let's try another one. See, I haven't tried these yet. This is first time. What's another good one? I don't have any good ones. I got these slanted ones. I don't want the slanted one. Tell you what. Let's find a good one. Okay, here's a cylinder. Now let's talk about the cylinder right here. It's still, remember, how do we find the surface area of something? We find three things, right? We find the top. We find what else? The bottom. And we find what? The lateral surface area. That's right. Which means the sides, which means this smooth part, right? The curvy part around this thing. I could go through an explanation of, well, I probably should. No. Let's just go through like this. Now, and how do you find the lateral surface area? Do you remember that? It's the what? It's the perimeter of the base, that's right, times the height. Now you could memorize, I mean, people out there, they teach it to you. I haven't even looked in the book. I bet you anything. Yep, sure enough. They give you these formulas, and oh my goodness, if you try to learn every one of these individual formulas for these, you just never remember it. Okay, this is real general. Oops. This is really general, and I like the way I do this much better than learning a specific formula for each one of these, okay? This works for cylinder, this works for any prism, any cylinder, all right, for the surface area. So I think this is nice. So if you were to find that area at the top, well, what kind of a figure is this? This is a what? It's a circle, isn't it? So how do we find the area of the top of this thing? So how do you, I'll put top. Yeah, that's right, it's pi r squared. And what would the bottom be? Same thing. So you just add them together, right? What about the lateral surface area? It's the perimeter of the base times the height. Well, where's the height? Let's do this. Let's go. Will yellow show up? Let's go red. Okay. Watch. From here to, like, if the center is here, then it goes to about right there. That right there would be the height. Okay. So that's the height. And so what about this? The perimeter of the base. Well, what is the perimeter of a circle? We just talked about that a few seconds ago. It's 2 pi r, right? So circumference of a circle, right, which is 2 pi r. So the perimeter of the base. It's not like you have to memorize these specific, 2 pi r times h and, plus 2 pi r squared. Books teach you that, to memorize it like this, and I think that's ridiculous. Just use this, and then you already know, oh, perimeter of the base. Okay, that means the circumference, that's 2 pi r times what? Times the height. So that right there is the lateral surface area, isn't it? Let me show you what some books do. They'll say this. They'll say, this is the surface area of a cylinder. Okay? Well, it's 2 pi rh plus what? Pi r squared plus another pi r squared, which would be what? 2 pi r squared. I've seen some books write it like this. 2 pi times r, what would it be? It'd be RH plus R squared. That would be stupid to write it like this. It'd be dumb to write it like this, okay? I just remember, find the top, find the bottom, okay, and then find the lateral surface area. How do you find the lateral surface area? The perimeter of the base times the height.
So, for every, like, a prism and stuff, you have to find the top and the bottom, and then add all of it up, plus the lateral surface area.
Yes. Yeah, you're going to have to watch this on YouTube because we went through all that earlier when you were taking a test. All right. So I don't memorize. I mean, wouldn't that be horrible? Sit there and try to memorize that formula right there and memorize something different for every one of those shapes. That would be kind of crazy. So I just basically remember one thing, and that's what's in this box right here. Find the area of the top, find the area of the bottom, which are the same thing. So that's kind of not even like two separate steps, is it? It's basically just like one step. Okay, find the lateral surface area. That's the key. How do I find the lateral surface area of any of these prisms and cylinders? I find the perimeter of the base, the distance around the bottom of it, multiplied by how tall it is, the height, and then I've got the lateral surface area. So what do I do with all three of these? Once I find the top, the bottom, and the lateral surface area, do what? Add them all up. That's right. Just add them all up, and then you've got your total surface area of that particular figure. What do you think? Does that make any sense? Okay. I kind of like this way better. Now, sometimes finding the top and the bottom may not be quite as easy as others. Like if you had a rectangle, okay, or a square, finding the area of the top would be pretty easy, wouldn't it? Okay, just base times height. If it was a triangle, it wouldn't be much more difficult, would it? It's 1/2 the base times the height. But now, if you start getting into like pentagons and hexagons, what is that though? The area is 1/2 the apothem times the perimeter, right? Okay, so sometimes these take a little bit of extra work, but if you can remember what we've done right here, it should make things a little bit easier for you. So let's do a few problems here. Let's do, this is 12.2. Remember we skipped 12.1. So this is section 12.2. It's page 834. And we are going to start with number 9. And let's go through Alright, I'll take it a little easy on you. I was going to have you do through 22, but I'm going to have you do 9 to 21. We'll just do the odds on these because I want to make sure that we include a little bit of each of these. I think if I had you do all 9 to 22, that'd be a little bit of overkill. I think this will be good enough for you to understand what we've been trying to teach here. Okay? So 9 to 21, just the odds. 9 to 21, just the odds. Alright. So that will be due tomorrow, right? Today's still Thursday, isn't it? Feels like it should be Friday, doesn't it? Feels like this whole year should be over. But keep on going. We're still in the Bell lap, right? We haven't finished. We haven't got to the finish line just yet. Keep running. Keep running hard. Don't quit.